Hello friends, myself Rinki Singh, Assistant Professor in IT Department at IMS Ghaziabad University Courses Campus. Today's topic is Infix to Postfix conversion. We know that there are different types of arithmetic expressions, or we can say that arithmetic expressions can be written in various forms. One of the most general form of writing in arithmetic expression is infix notation, that is operands, operator, operand, where operator exists in between the operands. That notation is known as infix notation. We use this notation in our day-to-day life, but along with this notation there are more notations like prefix notation known as Polish notation, in which operator is written before the operands like plus AB. And one more type of notation known as postfix notation, also known as reverse Polish notation, in which operator is written after the operands, that is A, B plus. Now, in case of infix notations, to specify the order of operations, we need parentheses. But postfix notation doesn't need any parentheses. There are no precedence rules to learn in case of postfix notation. So, because of this simplicity, computers use postfix notation. But we people in our day-to-day life uses infix notation. So to convert this infix notation which we feed into the computer to the postfix notation which computer uses, we need some algorithms. If there are small expressions like a plus b into c, we can convert this type of infix notation or infix expressions directly to the postfix expression. But when the expressions get more complicated, we have to follow certain rules for the correct result. One more reason why we need postfix representation of the expressions. As we know, compiler scans the expression either from left to right or from right to left. For example, if we have an expression, infix expression, a plus b into c plus d, we know that multiplication have higher precedence than plus operation. Then compiler first scan the expression to evaluate the expression b into c. Then again scan the expression to add a to it. And then the result is added to d after the another scan. So repeated scanning makes it very inefficient. So it is better to convert the expression to postfix or prefix form before evaluation. So this a plus b into c plus d expression in postfix form become a, b, c into, means two operands b and c are connected by multiplication operation. Then the resultant of this and a are connected by plus operator. Then resultant of this and d are connected by plus operator. Now, the evaluation of postfix expression can be easily done using stack. We also use stack to convert an infix expression to postfix representation. So these are the most common applications of stack, that is conversion of one type of representation of arithmetic expression into another type of representation, and evaluation of postfix expression. So to convert infix to postfix conversion, the first step, we have x as an arithmetic expression in infix notation, and we have to find out its corresponding postfix expression y. First step we do is we push a left parenthesis onto stack and a right parenthesis to the end of x. We perform this step to check whether we have scanned the whole expression or not. For example, we have this expression, then we will insert this right parenthesis at the end of this expression and we will push this left parenthesis in the stack. Now, repeatedly we perform step 3 to 6 until our stack is empty. We may encounter 4 things while scanning this expression. We may scan an operand, we may scan an operator, we may scan a left parenthesis, or we may scan a right parenthesis. So, if an operand is encountered, add it to y, that is postfix expression. If a left parenthesis is encountered, push it into the stack. If an operator is encountered, then we repeatedly pop from the stack and add to the postfix expression each operator on the top of the stack which have same or higher precedence than the currently scanned operator. And at the last, we add the currently scanned operator to the stack. If a right parenthesis is encountered, we repeatedly pop from the stack and add to the postfix expression each operator until a corresponding left parenthesis is encountered, and remove the left parenthesis from the stack. For example, we can see all these steps in this example. Firstly, we scan A. A is an operand, so we add this operand directly to postfix expression. We add this to postfix expression. Next, we scan plus. Now we look into the stack whether there is any operator of same or higher precedence on the top of the stack. No, there is no operator on the top of the stack. So we push this operator on the top of the stack. Next, we scanned left parenthesis. When a left parenthesis is encountered, we just push it into the stack. Next, an operand is scanned. We add it to the postfix expression y. Next, an operator multiplication is scanned, but there is no operator on the top of the stack, so we just push it into the stack. Then an operand C is encountered. It is just added in the postfix expression. Then an operator minus is scanned. Now, on the top of the stack, there is an operator multiplication, which has higher precedence than minus operator, so we pop it from the stack and add to the postfix expression. And lastly, we push this minus operator on the top of the stack. Then again, a left parenthesis is encountered, just push it into the stack. Then D is encountered, add it to the postfix expression. Then division is encountered. There is no operator of same or higher precedence into the stack, so just push division into the stack. E is encountered, just add it to the postfix expression. This, that is raised to the power or exponential operator is encountered. There is no operator of same or higher precedence on the top of the stack because division has lower precedence than exponential operator. Then F is encountered, add it to the postfix expression. Then a right parenthesis is encountered. We will pop from the stack and add to the postfix expression until a corresponding left parenthesis is encountered. So we will pop exponential operator, add it to the postfix expression, division, add it to the postfix expression, and then this left parenthesis and this encountered right parenthesis get cancelled. Now multiplication is encountered, no same or higher precedence operator exists on the top of the stack, so just push this multiplication on the top of the stack. G, add it to the postfix expression. Again, right parenthesis is encountered. So pop from the stack until the corresponding left parenthesis is encountered. So multiplication and minus are popped and added to the postfix expression. Then multiplication is encountered, added to the stack because no same or higher precedence operator exists on the top of the stack because plus has lower precedence than multiplication. Then H is encountered, add to the postfix expression. Then this parenthesis which we have added at the end of the expression in step 1 is encountered. So we pop from the stack multiplication and plus and add it to the postfix expression, and the parenthesis which we have added into the or pushed into the stack in step 1 is also get popped, and at the end we get this postfix expression corresponding to this infix expression. Thank you.